So now that we got our C++ code down, let's take a look at what it looks like in JavaScript. On the left, we have JavaScript, and on the right, we have our old C++ code moved over to VS Code in order to get a better kind of side-by-side perspective. The first thing you'll notice is that, well, I gotta have a little red squiggly right here. The one thing to understand about it is the compiler that's attached to the Visual Studio Code is not set up. That's basically my fault. I didn't go to the back end and download and work it through. But I don't normally code C++ in the actual Visual Studio Code. The reason for that is because when you have a compiler that's predefined, it has different libraries from what a very basic compiler will have. All your libraries normally get pre-installed with a bigger IDE than if you're using kind of the standard GCC sort of compiler. So that is a little bit of a difference there, but the setup in a general sense, I don't really like to go through it so often, and playing with compilers gets a bit tricky. So if anything, I just use a IDE like CodeBlocks or a IDE like dev C++. Here's my code blocks, and this is what we did last time, right? First, we're gonna start at the very top, first line. Let's go line by line and start comparing. In the very beginning of any sort of program, especially in the main program or main file, we want to include about as many libraries that we are going to be using. Some files may have their own libraries, but most of the case scenario, we want just about most of them to be in our main. With that in mind, we do the same kind of importing process. So we take other code or DLL libraries and we incorporate them into our program. But we do this using this particular line2 script for the JavaScript. This is how we will find the file by giving the directory of that file location. And from there, you'll be able to basically load up any JavaScript file essentially anywhere on your computer. But generally speaking, it starts from the current file location of where our index HTML is. So wherever that file is, you can put stuff around that file in the same folder, and you'll be able to directly just put the name in quotes of that file, and you're done. But there are other mechanics to that, such as relative directories and absolute directories, which get tricky. So we're not going to go into them too much yet. But other than that, the beginning starts pretty similar. We get all the libraries that we're going to use within our program, import them in whatever manner we need, and then we start off with some possible functions. While there's a bit of a difference here, the general kind of structure of our grammatical sort of sense of our two functions is very similar. In fact, so similar that our color coding is basically the same. But we want to note that the very first word in blue is not of the same type of command, right? On the left in JavaScript, a function is creating a function. It's saying, hey, I want to create something called a function. That's the purpose that it serves at that moment. For the void, that's basically saying I have a function that I'm gonna be returning something. Whatever that something is, as far as types go, integer, double, float, boolean, that's what I'm gonna put in that box for void. Otherwise, if I'm not returning anything, I'm gonna put the word void, as in that meaning. It's a void. There's nothing coming back. Don't expect anything. So that's the difference in the two pieces that are constructed. The reason for the absence of void in JavaScript is, again, notice the variables that we kind of are going to be looking at later, but there's no specifics to the types in JavaScript. It really, there is, but it doesn't care. It doesn't care what you return. It doesn't care if you're returning or not, right? It's automated in the back end. The big difference between a scripting language and a programming language. You're going to have a lot of automations that are either done by the runtime environment, in our case Chrome, or in Python's case, the Python 3.6 or 2.7 environment. Those are what dictate how things work. So while C++ is super bare bones, in fact, Python is created with C++, so that's something to know there. With C++ being as close to hardware as we can get, it needs those extra details like void. However, of course, we come back to our typical JavaScript space. We don't need those kind of specifics now. And that's the greatest thing about it. We don't have to worry about all the little details that would kind of slow us down in our programming. Normally, it won't stop us, but it would slow us down considerably. especially if it's a simple application we want to create just to help us organize or parse data and information. More than likely, you're not going to be using C++ if you're trying to create a quick macro application to do something for you, or something interesting like a game, like JavaScript game, for instance. So with that said and done, we see how those two are created. They still have our code block curly braces and the input for the regular braces. With that, nothing else is really different here. They still essentially require this sort of ending semicolon, although JavaScript doesn't care also for semicolons. It kind of gets the idea. If you're pressing enters, then it gets the idea. If you're actually coding with enter signs every time each line ends, then you wouldn't need to put any semicolons in JavaScript. But if you don't do that, if you don't code line by line and you code in a single line, then yes, you will need to put your semicolons, otherwise JavaScript will be confused. So that's kind of the idea there. While in C++, it's absolutely required. Always put semicolons. End of story. So one thing that's a little bit different, we see main function that runs a program on basically double click, but we don't see that same function. In fact, we kind of see it, but we don't, right? We see that this stuff here is existing, but there's no function that holds that stuff. There's no block of code that it is around it. But here, we see that code, but we do see our code blocks. In fact, the code blocks belong to the main function. So there is a oddity here. Let's explain that. One of the main reasons for this is when C++ compiles, we need a beginning point somewhere. So as you have many files of code and there's many functions, right? There's many things that look similar. They can activate, a print can happen, all this kind of interaction of code within it without explicitly telling the program where to begin. It won't really know which code to start from. So we use that nomenclature as using the main for that particular function purpose. Anytime we want to basically run the very first pieces of code, we would do it within the main if we're doing JavaScript. Now, C++. Now, if I look at JavaScript, we don't need that particular incentive for us. In fact, we're kind of dealing with something more particular to scopes. So if we were to say that main has this as its very first root scope, so the very beginning, so this is where that particular programming language begins, so this is the root scope, and it starts activating code from here. Everything else is basically going to be just a scan, right? So the top function gets processed and the print stuff gets processed, saved in memory for later. It doesn't actually run. But the very first line that actually runs is the float sum decimal. Now in the JavaScript situation, we don't have that sort of inner scope, meaning that it's not inside of any particular blocks of code. It's on the outside. It is anywhere within the script tags, and that's important to note. That's the big difference here. Meaning that in JavaScript, you can just start coding anywhere, and as the page is loading, you're able to basically activate the codes chronologically, written from bottom to top. And if you need functions, you can use functions. With that in mind, take a look particularly at that red line I've just drawn on both of them. That is what we would consider the root structure for both of those individual and for their respective grammars, for C++ on the right and JavaScript on the left. That root scope essentially states just run whatever is here. Now I can of course put tabs and start writing it up here, but that won't make a difference since those tabs are technically not used. So really it's stating that, hey, the first piece of code after the script should run, like activate. And if you have more scripts up here, well, then this file is going to be the file that activates first before we do this code. Keep that in mind. That's a very important piece of info, especially in the chronological order of things of our chronological program, which is just line numbers. Our, our timeline here is just line numbers, right? So as the program increases in line numbers, then that would essentially state that whatever's at the very top runs first. Now, it's not the same in C++. We can organize code all over the place, but whatever is at the top of the main function runs first. And that kind of separates the biggest difference between both of those languages. So with that said and done, we can kind of realize then, all right, well, there's nothing up here, so there's nothing that's going to run in JavaScript. We have a comment here. We're creating a function here, so technically the code is not going to run. It's going to be saved in memory for later. And then we basically close out the function block, we continue, we make some variables. So here's where the program starts. We create the variable here that is basically corresponding to the float in C++. Keep that in mind. Notice the difference. JavaScript doesn't care, once again, for the variable type. Just type in var, set it equal to whatever you want. Well, of course, give it a name first, but then set it equal to whatever you want, and then put that number or value or name or letter or function. We'll get to that in the future. You can basically store anything inside of these particular variables. Not the same for C++. So that's a great leniency that we have as developers to kind of lessen the obfuscation, well, to increase the obfuscation, which kind of reduces the overall control. However, it's just enough control for us to make certain tasks much easier for us in JavaScript versus C++. Looking at the array in each one of these, we'll notice a bit of a difference. First, I haven't quite created the most, how would I say, bare bones array in our C++. That would require some memory allocation with some functions, and then finding out the size of an int, multiplying it by the time, by the number of integers that I want to put inside of an array. But remember, in JavaScript, we don't care, right? We don't even have to be just integers. We can do all mixtures of an array, all separated by each a comma, and you can basically make this as long as you want. While if I was in C++ manually creating it, the same exact one, first I would not be able to, simply because it's a mixture. But let's say I was able to. Well, then we would have to state whatever that type is. So let's say all of them are strings for our argument. Then this string has this size and this other size. So you'd have to find a considerable kind of dynamic to the sizes of each of those contained in the array. And then you find all of them together for the total size of your array. And once you get everything, then you create it and then you save the stuff. And that's great if you know what's gonna be in your array. And if you don't know, then you're kind of playing with guesses. Like, maybe I'm gonna have 10, but never more than 10. And then you go to 11 and all of a sudden your program crashes. Maybe I'll have 1,000, but never more than 1,000. That's so much already. And then you get to 1,001 size, right? Array size, and then it crashes in your memory, or it overwrites something or causes some kind of craziness. Of course, we're talking about C++. We don't have to worry about that in JavaScript. And finally, for any debugging, these are the types of functions we're going to use. Console.log for JavaScript and printf for C++. Using these, they are a little different. You can already tell from the beginning. They are being displayed differently. But with that in mind, this is how we're going to be sending ourselves information when we're kind of programming, trying to figure out what's going on, if things are connected, if I did the right thing, or if I didn't put a typo, especially because typos happen all the time. You always want to use console log and printf in order to make sure that, all right, up to this point, everything's working fine. I can continue without worrying about whether it's working or not. If at any point in time you start worrying about whether you can run your program or not, it's too late. You should have checked. You should have checked earlier whether it was running by testing it out, just to show if there's some information coming back, like a print or a log of something. Just make sure, maybe you can put your own stuff in, like, hi, I'm in the function, whatever. We'll go around some of those techniques in future videos. But always be able to check yourself with these debugging tools. It'll make your life much better. And finally, in each one, we show how we activate the functions, and literally no difference other than the parenthesis color for whatever reason. Even differing from the parenthesis color from the original, which I'm assuming is the difference between a yellow parenthesis creating the function and a purple parenthesis activating the function, which there is technically a difference. Now we can see that difference with a color change in C++ Visual Studio Code. You won't see that difference here, and that's kind of where the ambiguity happens, and you won't realize that, hey, that's kind of the blueprint. This is how it's activating, if you haven't had me repeat that 10 times in the video. So with that in mind, we're basically done with these two. Now, of course, the end is this script and this script. We haven't talked about that much, but that's just HTML again. It's just contained inside a HTML document. It can be a web page. It can be just a file on your computer. It doesn't have to be anywhere on the internet. You can make these right on your computer and then open them up with Chrome or Firefox. So you're immediately able to recreate all of this JavaScript and then continue with further videos without installing anything. If you're watching this on the internet, on a computer, more than likely you're in a browser and you can do this as well. So it's always great to get started at some point. It's very quick to just pause the video and then copy and type copy, right? I promote typing in this video series. I would love to give you the code. It's just so convenient that it won't stay up here, right? So kind of push yourself to go through these videos and follow them if you are serious about learning this and gaining this skill. Then from there, you'll be able to be more familiar just by the fact of using it, compiling it, opening it, seeing it run, and that's even a personal motivation to continue. So from there, thank you for joining me today. The next video is going to be about Python, and we're going to be using these two again in a similar fashion. I'm probably going to be using the JavaScript example more, but I'll probably jump between JavaScript and C++ when going through the Python version of this video, and we'll be observing the same exact details, but in the Python, plus maybe some more little details that are specifically Python for its usage. Anyway, thank you for coming. If you have any questions on any ambiguous parts of programming, any questions that just don't make sense, why does this language do this but this one doesn't, put a comment underneath and I will take a look at and read every single thing that comes in, and if I get a lot of particular problems in programming, I'll make a video solution to that, as well as give some more background when it comes to showing languages and how they react differently. So thank you again for watching. Like and subscribe, and I'll see you next time for our next video in Python.